Okay, today's lesson is going to be on factorials. And the factorial notation looks like the exclamation point, but it's factorial. And so this is used for probability and statistics. Permutations is a common use for factorials. So if you see 3 factorial, that would equal 3 times 2 times 1. So 3 times 2 times 1 is 6. And for example, if it was 5 factorial, it would be 5 times 4 times 3 times 2 times 1. So 5 times 4 is 20. 20 times 3 is 60. 60 times 2 is 120. Okay, so when you see, for example, the 5 factorial, it's the first number that you see times 1 less than that, times 1 less than that, times 1 less than that, times 1. And all those numbers together multiplied gives you the answer. On most calculators, you will see the notation given, and it's just the exclamation point, but it's really, in mathematics, it's factorial. So just some practice problems to do that. We can just have the numbers, or we could have factorials written like that. So if you see this, and this is what you could use for permutations, you can easily simplify them by, we know that this is 5, well, we have written there, 5 times 4 times 3 times 2 times 1. If we multiply part of it, 5 times 4 times 3 times 2 factorial. So 2 factorial is just 2 times 1. And we rewrite the 2 factorial down below. Anything divided by itself reduces to 1. So that kind of simplifies the problem. So now we can just go 5 times 4 is 20. 20 times 3 is 60. So if we had that problem, we could use that intermediate step, and the factorials will cancel each other out, and our answer would be 60. So let's do another one. Another example. So we could say 6 factorial divided by 7 factorial. So you know that 6 factorial is 6 times 5 times 4 times 3 times 2 times 1, and 7 starts with 7 multiplied all the way down. So you should start to see a pattern. You can take the 6 factorial, because that's the smaller factorial, and then in the denominator you can say 7 times 6 factorial, because remember that 7 factorial is 7 times 6 times 5 times 4 down to 1. And here would be the same thing. Both of those things are the equivalent value. We just broke it out a little bit different. This is 7 times 6 factorial. But we know that 6 factorial is 6 times 5 times 4 on down. So I stopped there because in the numerator we have 6 factorial. So you would just stop whether it's in the numerator or the denominator till a point where we can cancel it out. So 6 factorial and 6 factorial, that would cancel each other out, right? Because anything in the numerator divided by the same thing in the denominator would cancel each other out. If we didn't do that, let's take a step back. If we didn't do that, if we just multiplied it all out, 6 times 5 times 4, I changed notation to just the dot for multiplication, times 3 times 2 times 1, all over 7 factorial, which is 7 times 6 times 5 times 4 times 2 times 1. So should see a pattern here. 6's cancel out. 5's cancel out. 4's, 3's, 2's, and 1's, they all cancel out and leave you just with a 7. So the answer would be 1 over 7. In this other term, the 6's would cancel out, and you'd still be left with 1 over 7, the same thing. Okay, so we're just preparing you with another skill set that you can use for probability and statistics type problems, mainly in permutations. So let's do a couple other quick examples. So we could say 8 factorial, and let's make it a little bit more complicated. Let's say we're going to go 3 factorial and 7 factorial. We can have multiple pieces in the denominator or the numerator. And so if you're looking at this, you can take maybe the largest factorial, because you want to simplify it the easiest. And to do that, you want to consider the largest factorials, whatever you can reduce the greatest. 3 factorial, that's a pretty small number. But the 7 factorial, that's a lot of numbers multiplied together. 7 all the way down to 1. And so identify that 8 and 7, they're pretty close. So a lot of the same numbers will cancel each other out. So you have 8 times 7 factorial and 7 factorial. So you can cancel each other out. They go to 1. They reduce to 1. And so you have 8 in the numerator. Well, we really couldn't do anything with the 3 factorial. And that's 3 times 2 times 1. So that's 6. 8 divided by 6. Now we can continue to simplify it further. A 2 is a factor of both of those. 8 divided by 2 is 4, and 3 divided by 2 is, or 6 divided by 2 is 3. So the answer would be 4 over 3. So we can have multiple numbers in our factorial. You can also use variables. So let's use n factorial all over n plus 1 factorial. This would be an example of using a variable. And so in our other example, it was 8 times 7 on down. Here we would have n factorial in the numerator. Well, if n plus 1 is the first number, n plus 1, the second number you would have would be 1 less than n plus 1, which would just be n factorial. So n plus 1 reduced by 1 is n factorial. And again, you can see the same number over the number would reduce. And your final answer would be n plus 1. So even if there's a variable, the numbers multiplied together is 1 less integer every time. Okay, so some practice problems for our assignment. So the first one we'll just do 7 factorial. The second one, (5 factorial divided by 6 factorial). The third one, (7 factorial times 4 factorial divided by 5 factorial). The fourth one, (4 factorial times 6 factorial), and we'll put some in the denominator. In the fifth problem, put a variable in there. n factorial divided by n minus 1. So that'll be your assignment for next Wednesday.